All right, so I flipped the page over, and flipping the page over now puts me into conversations for section 3-2, where I'm trying to get the lines to be parallel. I'm not given anything. I have to then prove it. I'm trying to make the lines parallel. So they're asking me, if you could pick any value for x, like what would you do to make those two lines parallel? So because I'm looking at alternating exterior angles, let's write that down, alternating exterior angles, because I'm looking at those, I say to myself, okay, if those two angles had the same measure, then the lines would be parallel. So as I go to solve each of these, if x had a value of 10, then those lines would be parallel. I don't know if they're parallel yet, but I'm saying if somebody gave me a choice and we wanted them to be parallel, I'd pick 10 as my angle measure, or as my value for x. Okay, what do we have here? If I'm trying to prove that these two lines are parallel, if this is a given transversal, and by the way, these are consecutive interior angles. So if I want these two lines to be parallel, I know these two have to be supplementary. So I have to know that 13x plus 15, that one angle plus my 20x is going to equal to 180 degrees. If that story is true, then these lines will be parallel. All right, so let's see what I'm looking at. Looks like 33x plus 15 is going to be equal to 180. And that 20 plus 13, it's a weird number, don't you think? All right, 33x is going to be equal to 180 minus 15. So it sounds like 165. So what is our x equal to? We'll just take a look at that. 165 divided by 33. 5. If x has a value of 5, then those lines are parallel. All right, so now we've got two proofs, and I want you to pay careful attention to how we go through talking about each of these proofs. And the one thing to keep in mind is if you're proving a converse or a theorem, you can't use it. So I can't say, oh, 3 and 6 are supplementary, so then A and B are parallel. I can't just say that because of the consecutive interior angle theorem. They want, we want to put some meat behind it so we can prove it and say it. All right. So what I'm going for is a statement at the very bottom. It's going to say, therefore, A is parallel to B. So that's what I'm looking for, these two lines to eventually be parallel. Let's talk about what we're given. Number 1, the measure of angle 3 plus the measure of angle 6 is equal to 180 degrees. And how do I know that's true? They told me. So we'll go ahead and just call that our given, get that out of the way. All right, so because I have these supplementary relationships, I know that, let's just talk about a plan first. So I know that 3 and 6 are supplementary. Okay, so what else can I do? I have to get myself back to my corresponding angles converse, my postulate. Because that's the only thing I have right now that Euclid gave us. So I have a choice. Do I want to talk about 3 and 7 being corresponding, or 6 and 1 being corresponding? I got to tell you, it doesn't matter. So if I define and talk about angles 6 and 1 as being corresponding angles, if I can prove that angle 6 and angle 1 are congruent, then I can get the lines parallel. So if I want the lines parallel, I got to get 6 and 1 congruent. Okay, let's talk about how I get 6 and 1 congruent. I know that 6 and 3 are supplementary, but let's start diving into 3 and 1 a little bit. So what I'm going to say is that angle 1 and angle 3 are a linear pair. How do I know that that's true? My definition of a linear pair. All right, so you should be thinking in your head, why'd she do that? Why does she need 1 and 3 to be a linear pair? How am I going to get to that conversation? Well, guess what? Angle 1 and angle 3 are what? Say it with me now. They are supplementary. How do you know that they're supplementary? My linear pair postulate. Don't forget about that guy. Your linear pair postulate is the one that says if you have two angles that are linear pair, then they're going to be supplementary. If they're supplementary, then they add to 180 degrees. Okay, so now I've got 1 and 3 being supplementary. Believe it or not, I don't have 3 and 6 supplementary yet. Let's talk about it. Angle 3 and angle 6 are also supplementary. Yeah, I had to go ahead and make that jump and say it. And how do I know that that's true? That's my definition of supplementary by definition. All right, here comes the big finish. Are you ready? If I've got 1 and 3 supplementary and I've got 3 and 6 supplementary, what do we know is true? Angle 1 is going to be what? Congruent to which one? Come on, come on, come on. Angle 6, and that is our congruent supplements theorem. The congruent supplements theorem guarantees that that's true. All right, rock on. Guess what's next? If 1 and 6 are congruent, then I can say A and B are parallel. How do I know that's true? That is going to be my corresponding angles converse. So he gave us a corresponding angles converse, and through that we can prove all the other ones. Guess what? I just gave you a present. Now that we've proven it, we can use it. Okay. Let's take a look at this one. This one is a little bit different because it's not asking us to actually prove one of our theorems per se. We're going to get to use them. So we have L and N as parallel. So let's go ahead and draw in what we know to be true. L and N are parallel. That's what we have. Guess what we don't have? We don't have J and K parallel. So these are the ones that we don't have parallel, and these are the ones that we do have parallel. So we can go ahead and make sure we have that noted. All right, so let's see what else we have. We have angle 12 and angle 8 being congruent. Oh my gosh. Angle 12 is way over here, and angle 8 is way over here. Now, angle 12 and 8 don't share a transversal, so we're going to have to figure out a way to jump our way from family to family to family. Do you see this 1, 2, 3, 4 family? They're different from my 5, 6, 7, 8 family, and they're different from my 9, 10, 11, 12 family, and somehow I have to find a bridge from each one. All right, let's see what we have. I have given line L is parallel to line N. So since I have that given relationship between L and N, let's see what I have that can be true. L and N are parallel, and I want to prove J and K are parallel. So if I've got L and N are parallel, I can talk about these two families. Transversal K, and I can talk about all the relationships between 1, 2, 3, and 4, and 5, 6, 7, 8, because I know that they're parallel. That is my given. And guess what else they gave me? Angle 12 is congruent to angle 8. Okay, so let's not talk about this yet. Let's talk about these families. Okay? All right. What do we know? let's focus on angle 8. We can say that he's corresponding to angle 4. We can say that he's consecutive interior to angle 3. We can say that he's alternate interior to angle 2. I'm going to stick with my corresponding. So I'm going to go ahead and I'm going to say that angle 8 is congruent to angle 4, and that is my corresponding angles postulate. That's the one that we got first. If the lines are parallel, then these cool relationships exist between the angles. If the lines are parallel, then 8 and 4 are going to be congruent because they're corresponding angles. Alrighty. So are you seeing where we're going with this one? Do you see it? Because if I have 12 congruent to 8 and 8 congruent to 4, what do you want to say next? Angle 12 is going to be congruent to angle 4. And who lets me say that? That is my transitive property of, careful, congruence. I don't have any numerical values. I just have angles and things. 12 and 4. Do you see it? So if the lines are parallel, 8 and 4 are congruent. Got it. We were given that 12 and 8 were congruent. So now I've got 12 congruent to 8, 8 congruent to 4. I can link these and say that 12 and 4 are congruent. Guess what I got now? You got it. I got my parallel lines because 12 and 4 are corresponding angles. So I can say that line J is parallel to line K, and I can easily say that that is because of the corresponding angles. Careful here, converse. The converse is the one that proves the angles are congruent. How'd you do?